Oh, something.
He's fine. Well, Iron Core worked this morning, so.
Oh, one big thing going
Just do this if it's okay. So this morning, we want to show you some of the work that I've been doing off to the side, trying to get a new event store architecture based around Postgresql for our new Node.js development for the for the rewrite that we're doing. So first, I know that some of you have a lot of experience with event sourcing already, some of you don't. So I know that some of you have already seen the movie, but I'm going to talk about the concepts first and then jump into what my current tooling looks like. And what I'm really looking for here is really for feedback. This is work that's very heavily in progress. Start getting some ideas of what do you see in here that would work for you, not work for you, what's missing, what kind of things might help, like some of the development you do today with our existing event store architecture. And along the way, I'll try to explain why we're basing this around PostgreSQL instead of some of our existing tooling. Any questions before I start? So event sourcing by itself, you could think of it as just a totally different persistence strategy, a different way of persisting the application state. But first, maybe let's talk about some of the ways that we've done persistence in the past. At the top, what Martin Fowler calls transaction script style, really just writing procedural code, go grab data readers, data sets as you need them, work through it with straight up procedural code. For people of my generation, that's how we cut our teeth doing development, doing classic ASP or PB6. It's not something you would necessarily want to do today, but it's still probably very common. Getting a little more advanced, I mean, another way to do this is what we see coming out of the Ruby on Rails world, where they'll use active record patterns to do straight up CRUD. Really just writing a code-centric wrapper directly around our database. All we're really doing is, it's kind of what I call myself the peanut butter architecture. We're just kind of pushing some peanut butter data back and forth to the database and pushing it around the database. But we've got one simple model that we're working on. And then I'm going to talk the comparison quite a bit. For me, in my journey as a developer, it was really going through almost this stage. For a while, when the Eric Evans domain-driven design book came out, people were trying to do these very rich domain models, trying to embed all their business logic, these rich data models, these rich domain models, and then trying to persist those things with heavy tools like in Hibernate or ND Framework. And what happens, I know some of you, I know we have in Hibernate here in the shop, and I'm sure some of you used ND Framework in other places. You end up fighting a lot with the persistence concerns on what should be business logic code. There's always a lot of fight to go from the model that you want for your business logic to whatever model the database has to dissolve into. Plenty of times when you're trying to pull things in from the UI where I don't want all of the domain model. I want part of it, I want some of it, or I want more. So you're fighting all the time with, is it going to be lazy here? Is it going to be eager fetch? Doing all kinds of virtual proxies, you're generating a lot of work for yourself. I'm making this point because as we get farther in and start talking about event sourcing and things like command and query segregation, why things like CQRS aren't completely insane, like I thought it was the first time I saw it. It's because there's a tremendous amount of work in doing this, trying to use a single model for the data representation for all concerns, be it business logic, the database, the views that you feed. We incur a lot of friction, and the extra work that may be looking like we hit with CQRS is offset by what those would be. And then lastly, we use a lot of micro RMs here at Petapoco. To me, I'm a little biased. I think micro ORMs are just a much smoother way of doing old-fashioned transaction script procedural programming. It's a lot cleaner model than data sets or data readers, but I think it's still pushing you down towards very procedural coding. I think it's great for CRUD. I think it's okay for reading the view model, reading read-side models. I don't think I would ever want to base a heavy, rich domain model around it. But that's just my bias. So flipping the switch a little bit. If we were using event sourcing as our persistent strategy, what we're saving now, instead of trying to constantly model, update an existing model, like a standing state, what we're going to do instead, we're just going to store all the changes to the system as little event messages. Typically, we're just going to take the little event objects, we're going to serialize them in JSON, we're going to stuff them in a database table, a document database. I've seen other people try to use file systems and other wonky things. For us, it's going to be a real grown-up database. The core system of record, it's the events. We may project that into other views. We may copy it into a reporting database, but the system of record is the raw events. So, some possible reasons why we'd want to do this. I've got 2 slides, Corey, so let me get the second one before you jump in. So some possible things. It can be very expensive to update data in a database. So by only appending events onto the database, we're always inserting. Josh, I'm not misstating that, am I? Updates are more expensive than pure inserts? Okay. And as well, if we're just writing the events, we may not have a lot of relational integrity, another way of generating things in the database faster. We may want to do temporal querying. I'll talk about that more. We may want to say, what did the world look like at 2 o'clock yesterday? By using an event streaming, event sourcing, that makes temporal querying much easier than it would be otherwise. We don't have to keep an exact copy of what the state was at every time. We can just replay the events up to that point in time. This one's a big one for me. If you haven't used Hibernate or Entity Framework a lot, you may not feel this pain, but I certainly did. There's a really famous paper out there by a guy named Ted Neward. Looks like the dude from the Great Lebowski. That object relational mapping is the Vietnam of computer science. I thought it was a silly paper when I still believed in Hibernate, but after a few years of fighting the lazy, eager, this, that, or the other, he's probably right. Okay, the main reason, or I think one of the biggest reasons, and what we'll probably use it for in a lot of places. The great thing about event sourcing is it gives us a record of how we got to a certain state. It's good to know what the state is, but there are so many things we're going to do with business processing where it's important for us to understand how did it get here to support business decision making, maybe doing some kind of complex event processing, understanding how long did it take somebody to answer the phone. Using event sourcing gives us a lot of tools to reason about that. Okay. Before I came to Extend Health, Josh Arnold, one of our former colleagues, and I were on worked for about a year in a failed startup, which fortunately failed before it took down my marriage. What we were going to do, we were going to make a much more efficient hospital operating room. We're building an application on a giant monitor in the operating room, would tell you the state of the operating schedule, what surgeons were scheduled, where are the patients at, is everything ready, show nice yellow and red alerts for, hey, you're in danger of being late, hey, there's something new added, trying to make things flow faster through a hospital operating room. So applying this to event sourcing, which is exactly what we did, it made sense in this particular case. Just thinking about the things that happen. Surgeons arrive, or they're late, or the doctor, the surgeon, the nurse surgeries start, they end, maybe they get rescheduled, maybe surgeries get added to the list. Patients move to very different places. All of these things kind of go into helping us understand where are things at for the operating room. So somebody at a glance can start to look at this board and say, well, we've got a problem. We need to hurry up, or no, everything's good. Let's just go on. So we persisted these kinds of events. We persisted them, in our case, to a RavenDB database. Just tacked them on to a collection in the Raven. Worked out real smooth from the storage room. But again, talking about what we have to display to the actual users. We're not showing them a stream of these are the things that happen. Maybe we would have later. What we need to show them is the current state. How does that resolve to a two-dimensional array of the world? Okay? And then along the way, again, trying to reason about things. Performance factor, it was something like if you're a football fan, it would be like a quarterback rating, or if you're an NBA fan, the player efficiency rating. One of those made-up statistics that try to judge how well you're doing. A lot of alarms, using the events to know, hey, the patient arrived, but they're really later than they should have been. Throw a big flag up, you need to start hurrying, or the surgery's going to slip and the schedule's going to slip. Okay, so we're obviously missing some big things. And how do we get from the raw events to the data that the UI can use and do something about? Obviously, going to have some reporting later on, and it's possible we were showing a board per operating room, or really per a unit inside of a hospital. What if you wanted to start summarizing across hospitals? What if you want to summarize by a doctor who's doing things at multiple hospitals? There are all kinds of views we could hit that we'd have to pull out of all these magic stream of events. Okay. So the missing piece, event sourcing doesn't necessarily imply that you're using CQRS, but they tend to go together pretty often, and they will for us, I believe, in this case. So command query responsibility segregation. Not to be confused by the old object-oriented command query separation. That's slightly different. It was first coined by a guy named Greg Young. And I'll freely admit I sat in Greg's talk in 2008 when he was first presenting this at a conference, and I thought it was completely insane. It looked like an extraordinary amount of unnecessary work to me to keep all this additional work, the two models, to transfer things back and forth. I've come around. What we want to do with CQRS is we want to use completely separate persistent models for what we're writing to. We're writing events over here, and somewhere off to the side, we're going to have a persistent model that represents the data as the user interface or the clients need to consume it. Something magical in between the write side and the read side is going to sync these things up. So we're going to talk about projections a lot here in a little while. And what I mean by projections, it's taking this raw event stream data and kind of compiling it into the view, a totally different shape of the view. I know a lot of our applications, we do this today. You'll hear the term eventual consistency. So how many of you used RavenDB for some daily work? So how many of you have been bitten by the wait for non-stale results thing? And let the record show that the exact same hands came up? RavenDB is an example of eventual consistency. You're writing the raw data to the Raven database, but when you're querying, it's actually querying against a copy or a projected copy of the data, unless you're loading exactly by ID. So when you write data to the Raven database, you may not be able to query against that data and have the results that you just put in available right this very second. But it will eventually be consistent. This is eventual consistency. It's potentially a great thing for scalability, being able to keep up with data flowing into the database really fast without having to build up this fancy read size stuff as you go, but it causes a lot of problem because of the eventual consistency problem when the read side gets behind. This, from the talks I've had with other developers and other organizations, eventual consistency is the big hurdle that stops people from wanting to do this, to do the CQRS type architecture. Right. So the read side model is serving different goals. It is to be exactly what the user interface and the clients need. So instead of trying to write to one set of database tables and using lots of crazy joins to get the data shaped the way we want it, or to pull that one domain model and use something like AutoMapper to always be transforming it to what the view needs, we'll just write what the view needs to the database and have it ready to go. So when the client runs, things can generally run pretty fast because the data is already in the shape it wants. So that's why I spend so much time talking about the heavy ORMs and all the work that it really does take to try to use one model for everything. That it's not really true. There's a lot of work in constantly transforming it as we need it. So the CQRS isn't necessarily more work, is what I was trying to drive at. The read side model, we use just denormalized data and relational databases. Other places we're still using RavenDB documents. I think what I'm going to demonstrate here, with PostgreSQL we have the ability to do anything, but I think it would probably most likely still be documents. But that's to be determined. Okay, so the key part of that operating room automation thing we were working on, at the end of the day, it's all about process improvement. We need to be able to understand, why did the day go the way it did? If we had a day where everything was running late, we want to try to do some root cause analysis. And the way we were going to do it in this system, we were going to take the event stream and we were going to allow you to fast forward through it, to animate the changes. So turn it up to 20 times, 30 times ahead, and you could zip through and see what the board looked like at any point in time. Because all we were doing is just playing the events from 0 to 10 a.m. to see what things look like at 10 a.m. So as a decision-making tool, this was going to be fantastic for doctors to understand, why did we go wrong? What happened? We were late because of this one thing, and it snowballed everything else. Where was the bug that went ka-choo? That was the great thing about event sourcing in this particular application. This is my thought. Maybe I'll let some of you guys weigh in on this. The places where I'd be looking for event sourcing, because I don't think you would use it everywhere. I think just a basic CRUD-centric system would work if it's simpler, but I'm looking for applications that are very workflow-centric, user interfaces that are very task-oriented. I don't think these things have to go together, but people who build CQRS in the back end are usually looking for very task-centric user interfaces. That fits very well with the CQRS model. You're not updating a row in the screen. What you're doing is you're performing some kind of task. I'm capturing that I've rescheduled it. I'm capturing that the patient arrived in the such and such room. Any place where you have these temporal querying, where you need to say, what did the world look like at 2 p.m. yesterday? Event sourcing is fantastic for that. I would argue that it's valuable where you have very deep domain logic, especially things that are time-centric, places where you want to do the complex event processing. Is seeing this change to the current state should generate this. Go send out emails saying everything's bad, whatever that's going to be. This is a possible strategy for doing systems where you need a lot of scalability because of or especially where you're going to have a lot of writes, because of your ability to disconnect the rate at which you're taking in state changes from building up these fancy views off to the side for the client.
also add that, like, for our case, we need to store the audit trail history of changes to a customer record. So it kind of goes along with one of the bullet points, but more specifically, with HIPAA, you have to store all changes to a customer record. So.
And that little thing you just said. So, proposal for us, and remember this is wrapped around the idea that we were probably using Node.js for this development work. So, proposed event sourcing architecture. We're going to use the Postgresql database, open source database, as our backing store. I'll talk more about why we want to do Postgres, but so far it's looking very solid to me. Everything's going to be JSON. The events, the aggregations, the views, the projections, right now, everything's going to be JSON because everything speaks JSON. It's very easy to deal with and parse using JavaScript itself. Every programming language that we're going to use has a strong JSON parsing capability. I want to define the projections in JavaScript. I'll make that concrete in just a little bit. Maybe a quick show of hands. Even if you're not full-blown guru, how many of you know JavaScript? And for the record, every hand in the room went up, making it a pretty nice choice to do this. The topology, we're going to have a Node.js and NPM client, package client, to use to integrate with the event store. We're running JavaScript inside of Postgres itself, but we have a client that's already pre-built to interact with the Postgres pieces. From your angle, with the timeline we're talking about, it's safe to assume that we're going to be able to use Harmony features in Node.js. So we're going to be using generators as opposed to pure callbacks or promises. And that the client that's in there now is based around generators. If you've done Node.js work in the past, we're going to get away from callback hell. It's going to be a lot smoother. From my point of view, I don't think we would have pushed down the Node.js path if we hadn't gotten to use generators. Or I think we would have been much more hesitant. There's a possibility. We haven't really discussed this much, except in passing. We're using Event Store today with our .NET applications, storing in SQL Server. There's a possibility down the road that we could take what we're building here and put a .NET client on it, still using the same back end of the Event Store. And maybe we could retrofit this to existing .NET applications. Maybe. JavaScript's going to run everywhere. Okay? Client, web application, database. That might be something that we can utilize in a strong way. So why are we going to use Postgresql? And I'll have to admit, I've never used Postgresql before this. And it's been a very pleasant surprise. It does a lot of things I don't really expect databases to do. The biggest thing, I think, for us, the JSON integration features with PostgreSQL are already very solid. The new version that's coming sometime this year, and Corey, I haven't looked to see what's going on with this, but the next version of Postgres makes the JSON storage and querying much more efficient. It's actually storing the JSON as completely parsed out in kind of a BSON binary tree. So querying within the JSON documents is going to be very efficient inside Postgres. You can even create, on our read side models, we can even create indexes to search through the JSON documents.
And in 9.4, it's also auto-indexed, so you don't even have to create indexes manually.
And that's even better. Postgres itself, it embeds the Google V8 JavaScript engine, the same V8 engine that powers Node.js, the same JavaScript engine that powers Chrome. So not only are we beginning to run JavaScript everywhere, at least between the web server and the database, we're more or less running the same runtime. So I think we can feel a little more confident that we'll be able to share JavaScript between the two places. So we have quite a bit of investment in RavenDB as is for a document database. I think we're not entirely happy with some of the grown-up DevOps type features of RavenDB. Seeing a lot of head nods. Going to Postgresql, I think we can get the same kind of document store abilities, but have something that's much more robust. This has been around a long time. The infrastructure needs, the DevOps kind of things, the replication, the backups. I think everything is going to be much more solid in PostgreSQL than we've had trying to live on the edge in RavenDB, but still get some of the development time advantages that RavenDB has given us. For the sake of making the projections work and the eventual consistency kind of thing, PostgreSQL has kind of an interesting asynchronous pub sub support inside the database, where you can make asynchronous notifications. I guess you capture events, and it's happening inside of a stored procedure, which I never thought I'd ever write one of those again. Inside of stored procedures, I can asynchronously notify listeners that, hey, I got some new events. Maybe you want to wake up in a minute and go write up the new client-side projection. With PostgreSQL, it's still a relational database. If having relational database tables are valuable, we can do that. If you want to treat it as a document database and just stuff raw JSON in it, we've got a great model for doing that as well. The kinds of things we do with Raven, we can do with Postgres. And then finally, we're going to be able to use it as an event store. So we're going to be able to mix and match some of these persistence paradigms inside of one database. We did look a tiny bit at what is Greg Young's event store product called now?
It's an event store.
It's a little bit of a problem because there's several products out there that are just called the event store. I think one of the advantages of using PostgreSQL, being able to put everything in one storage as opposed to having an event store here and the regular database for the things that don't fit into events. This should help you. Postgres should help us collapse down and simplify what we have to deploy.
So is the pub sub support, is that just more robust triggers, or is it better than that?
It's not robust triggers, it's just the ability to asynchronously notify something. It is just publish, subscribe.
Even outside the database? Or
Yes.
And it's asynchronous rather than in the transaction.
Yeah. Well, the notification will not happen if the transaction fails. But the notification is asynchronous, so it's not blocking. So the database can go as fast as it can possibly go and just pop out the messages for someone else to do background processing to do our eventual consistency type projections. Okay. So the event capture, what I have today, the client, you can capture either one event at a time. You can capture multiple events for the same stream. So just a little bit of nomenclature. What I'm calling a stream, and this is taken from Greg Young's event store, a stream would be a logical workflow, a process. So in the case of the user, one user would have its own, he or she would have its own stream. So all the events, password changed, something policy accepted, all those events are tagged to that stream. So we'll be able to reason about that one stream in isolation. The event capture, it's all transactional. Within one transaction, be able to capture the entire batch. They're all going to succeed, they're all going to fail. I know that's been an issue on some of the projects we've had when the event store is not playing completely nicely inside the transaction, the original command capture transaction. we're going to have much more power over that with the architecture I think we're talking about. So the projection types that I've been considering today, and only 3 of the 4 are done or demonstrable. We might want to do, I think what I focused mostly on is creating a document view per stream. So taking the case of a user who's changing his password or changing his address, or all those things are going to be, we're going to have a view side document through a projection that tells you this is what this is who the user is today. This is their current state, where their address is at, and what policies they've accepted, the standing state. I think that's going to be very common. I know in some of our other work, I've seen a lot of use case where certain events, certain named events happen. We're just keeping almost a straight one-to-one projection of a view of that event. So you can create a projection record, projected view per event type. Then getting into some cooler stuff would have been nice in some of the work did a year or 2 ago. Being able to aggregate views across streams, like being able to say, you almost always have some kind of dashboard at an application that's telling you you've got 5 open issues, there are 10 things in flight. Places where we want to keep an aggregation across all the streams. So projections might be able, as events happen that would change that aggregation, may be able to kind of queue those up and apply them one by one in the right order to keep that application level or system level aggregation. Something I haven't tackled yet, some categorization. So we can say, again, taking these users. What if we want to have a summary roll-up by state? So events flow through, and as those events flow through, we update the record. If they live in Missouri, we update the Missouri aggregate. If they live in Montana, we update the Montana aggregate. Right? I was thinking here about the portal work and aggregating by client. Josh, I thought that this is something that we did kind of do on an ad hoc basis with the portal work, but having this formalized in a more robust way would have been nice. So when will the projections run? Years ago, there was, many years ago, there was a Saturday Night Live skit one time about the change bank, a bank that did nothing but make change for you. And there's this interview with Kevin Nealon saying, 3 nickels and a dime, 2 dimes and a nickel, we can work with you. We can do whatever you need to do. So that's what I've been thinking about here. Since we can run JavaScript in either the database, the Node.js server, and even crazy enough in the browser, I want to have a model where we can specify the projections can either run synchronously as part of the event capture. So as you capture the event, Postgres itself will update the read side views at the same time. So if we come into a circumstance where we have very few writes, but an extreme number of reads, it probably makes a lot of sense to do the updates synchronously. And again, this sidesteps the eventual consistency problem, with the side effect that is potentially less scalable. If you have a lot of writes but very few reads, what we might do, one of these kind of bottom options, and especially with the aggregates, we can't be locking the aggregate view all the time. We're probably going to have to farm out to some kind of background process and queue up, hey, can you apply all these events to the aggregate? So as needed, we're going to be able to mark some projection to say you run asynchronously. Just catch up as you can. We're going to do the eventual consistency thing. In other cases, again, for the case of many writes but very few reads, maybe we say that we're just going to perform the projection, we're going to execute it on demand as needed. So if you have some kind of roll-up view that's not looked at very often, we can just play and replay the event stream through that projection right then and there. Obviously, it doesn't help you if you need to query against that read side, but it's an option. So, where the projections will be executed. Synchronous projections probably just run directly inside of Postgres. That way I can take advantage of Postgres' own row locking, probably be very efficient. Doing things on demand, we haven't thought all this through, and some of this is we're going to adjust to whatever the business needs we hit, but we could do the projections on the Node.js server itself. So especially if we're getting into historical views, so instead of bombarding the database with all these, tell me what the world looked like at 2 p.m., have it just write down, have the client just grab the raw events and let it replay itself. Try to move CPU load off the database into the Node.js web server. I know this isn't quite as draconian as it used to be, but one of the things I had browbeat into me as a younger developer and architect is you try to protect the database as much as possible. The database has classically been the bottleneck for scalability. You don't make the database work any harder than it has to do. And we're kind of going backwards a little bit by shoving more work into the database. I think we're feeling pretty confident about our ability to scale and to cluster PostgreSQL, but still, if we have the ability to offload more CPU-intensive tasks off somewhere else, we will. Something I have not tackled at all, I think we're going to have a background service independent of the database to handle the asynchronous processing, the asynchronous aggregation. Not sure what this looks like. There's some existing tooling to do this with PostgreSQL. I can't make heads or tails of it. It's Python-based or in straight C. There's a slim possibility that this might be our Golang trial run, maybe. There's also, it's also quite likely we'll need a command line service for recapitulation. If we change the shape of projections and we need to replay events to update the projections on a deployment, we'll probably have to have some kind of command line tool to do a lot of that work. And I really have no idea what that's going to look like yet. I was going to work on it 1 week, and then we kept having tons of validation problems, and I got distracted. I will get those diagnostics for you someday, Daryl. There's also the possibility of running these projections on the browser itself, so that the hospital operating system, where we were doing the animation, speed it up 30 times and show me what the day looked like, run. That kind of thing, it might be helpful to just shove the raw events down to a browser and let them run through it on the browser. I want to see what it looks like at 2 p.m. Andrew, I'm going to make you start singing in the back. It worked very well for us. And we're talking about JavaScript. All right, so enough of that. But you guys are starting to wonder if this is really ever going to happen. So, what a projection might look like. So, I'm going to guess that some of you may have either read some fantasy novels in your past or seen some Lord of the Rings movies. I'm not going to ask because I know every hand would go up. So, let's say our problem domain is tracking a quest. We have a new kind of aggregate, and when we're setting off on a quest, we're going to have events like, well, we're going to start. We're going to make it to the end of the day and track how far we've come. We're going to reach towns. How long did it take us to get to Moria? How long did it take us to get to the eye of the world? We're going to recover items. We're going to gain characters. We're going to lose characters. Things like this are going to happen. So, I I forgot to mention it. This is actually defining the aggregate. Today in our work, we're performing the aggregation in .NET classes. Since I'm thinking with this model that we use the same projection support to do our aggregate. I do have existing code that does snapshotting, for those of you that are already familiar with that. But to define our projection, so the events coming in, the name of the methods here inside of our little JavaScript object, quest started, town reached, in a day, quest ended. These are the event types that are valid inside of this string. So the first time we capture an event for a new stream, a new quest stream, probably going to be a quest started, but regardless. If we're starting from scratch, there's a reserved function, that $init. This is just creating, I want you to create like the default state of this document. So in our case, you just say, well, if the quest is starting, it's going to be active. We haven't traveled very far yet. It's 0. I don't know where the location is yet. And an empty array for members. I don't know what it is. You're just setting up defaults. So the first event comes in, when this quest started. It's going to run the $init. Now I have a document. You see this method here? You're going to take in the existing state and the event itself. This event is going to be a quest started event. So from this structure, I'm going to take some state from this event, and I'm going to make the necessary changes to my existing state. So active is true. The location is the quest. The party of the quest has to be wherever they started out at. So if we're leaving Rivendell, if we're starting a quest from Rivendell, our location is Rivendell. The members of the party, the Fellowship of the Ring, it's the initial bunch. Boromir hasn't died yet. Frodo hasn't run off. It's who they started out with. You guys get this. You guys are getting this completely. Don't say you're not.
That's what's fun.
So, quest ended, members joined. Members joined, members departed. The event is telling us who joined and who left. So updating the projected view, we can just reach into the existing state and constantly change it. If you read other people's explanations of this, it always starts with, well, first you have to understand the lambda calculus, a bunch of pedantry, and they'll eventually talk about fold left. So if Bob was in the room or other functional programming fans, this is fold left. Or for those of you who are comp sci majors like I wasn't. So how does this look as something to use? I'm not just doing this not doing this necessarily to show off. This is something that's proposed for us to use in daily development work. So any thoughts about using this?
I'm trying to understand what part of the event sourcing or CQRS system this is. Because this is an aggregate that has a current state that's built up by a series of events. A new event can come in, modify the state. Where do the commands play in to turning into events?
I'm not covering that at all. I'm strictly in storage.
Okay.
I feel like the in-event store made a mistake by binding the event sourcing too hard into the command structure. So I've done absolutely nothing, Mike, to work on that. The only thing that I've supported so far is your ability to request the current aggregate state. And that it is using the snapshot built in. Specify however many events, keeping a record, like say every 5, you just rebuild the aggregate. But when you ask for it, it's like taking that to be a little more concrete. Say that you're receiving some kind of command. You're trying to process in your Node.js system that there are some people leaving the quest. The first thing you need to do is verify, are these people really part of the quest to begin with?
Right.
Because if they're not part of the quest, then this is invalid input, I just need to reject the whole thing. To do that logic, you have to pull the current state of the quest as it is. All right? So inside of our event sourcing, so it's super clear. But I request the client the snapshot. Behind the scenes, I ask for the snapshot for a particular request. How is the search for Alder's orb going? Right? What's the current state? Who's involved? You guys know. A lot of you guys know what I just said. When I ask the event store, it's going to go look at, all right, this is the stream you're looking for. Do I have a current snapshot of that? Yes? Okay. And then you ask how many events have come in since the snapshot was taken. And you take those extra events and you play those on top of the snapshot using this code to transform it. Or if you don't have a snapshot yet, you just take all the events. You start with this initial data set, initial state, and then you run it through these methods to add its changes until you get the correct snapshot view coming back out. Does that make sense?
Yeah, so I mean, I think what you're saying then is that a different object, more of a domain object with the business logic in it, that checks and validates commands and stuff like that, would offload to this object to know what the current state is in order to make decisions, but that would be logically separated.
Yes. So what I think it would do, I think you would end up with something kind of a backbone look and feel, or maybe even a React, where you would say, I want your real aggregate, your real thing that has the business logic for governing a quest. You would feed the snapshot into it as its constructor, and it may mechanically just add methods to become a real domain object, or not. Or we might do it in a more procedural transaction script kind of way.
You could think of it a lot like a saga and a saga state.
Okay.
I haven't gone down that path yet, Mike. I've been concentrating strictly on the persistence and the aggregations.
So effectively, you're composing the event every single time you're getting, or every time you're getting a new event, you're copying the state.
Not every time. Not every time. The snapshotting is configurable.
Just curious.
It keeps it from having to run through the entire stream every time.
And I understand the snapshotting, but basically every time you're getting a new event, you're making a copy of that.
No. Where did you get that?
So if you're going back,
Question.
are you storing the events individually somewhere?
Yes.
Okay, I understand that.
Okay, so looking at the storage. So just Google how to build your own event store, and you'll run into a big paper from Greg Young. And it's going to look remarkably, coincidentally, a lot like what I've done here. So we have a table.
Not quite, but
It's very conceptually similar. We have a table that gives you just the top level view of the stream, what version of it is it, what type it is. I'm utilizing this table to store the snapshot. Then you have an event table. You have one event table for all the events. That might change based on optimization. We might create an event table per stream type. We might not. That's to be determined. Any thoughts?
Where are you doing the projections?
Say that again?
What's the projections? Where are you actually doing those?
So today, the only thing I have supported so far, the projections, I'm only supporting the synchronous projection model, so it is happening in the database itself as part of event capture. Soon need to tackle the asynchronous eventing. So it was what I was saying about the background processing and Postgres notify PubSub. We'll probably offload that to some kind of other process, even if it's doing nothing but just queuing things up and then poking Postgres to run the projections.
Can you show them what the projection looks like?
Yeah. And I'm guessing you'll be able to have like multiple projections.
Yes, yes. So from the same, it is not a one-to-one for a stream. There are different views. You can look at summary views, different detailed views. There's no limitation on how many different projections you can have against the stream type or an event type. My thought is on a case-by-case basis, you would be able to mark those as this is synchronous, this is asynchronous. Getting into more of the raw code. All right. I've slept since then. I don't remember exactly where it is. But we have a model. As the event source starts up, it loads all these things into memory. I'm actually shoving the projections into the database itself. Sweep through a folder, grab every file, shoves it in the database. The database initializes. It pulls these things in. I wrote a very, very crude subset of a common JS loader inside of Postgres itself to do some of this. So these things are organized in a collection. It knows what projections apply to what events and streams. So as you capture an event, you immediately go, give me all the projections that match this stream and event, and just pounds through those, update yourself. The difference here, so you see these two methods, one at the top and one at the bottom. Process event and apply event. Come up with a different name later. One of them is going to be capture this event to yourself. And that's going to be either notify something that you need to update the projection or do the work right then and there. And the separate one, this code right here, like this. So this one method right here that I've got highlighted, this is applying the actual projection, doing the actual transformation. So if it's going to be a synchronous projection, like if you don't want to do eventual consistency, you want the read-side view to be updated as part of the same transaction event capture, you would use the synchronous model, and this would happen in line with the event capture. So just going back and forth a little bit, because I can't remember the this may have a bug. I'm a little harder on the mechanical equipment, so the trackpad on my Mac never works. So I kind of live with these limitations. The code, this method that's highlighted, this is what's doing the transformation that's defined over here. And it's not a whole lot of code.
What's persisting the event?
there's other stuff around it that's controlling it. This is nothing but the transformation.
Nice. I'm just curious.
So there's a lot of pieces, but there's like a projections, think of it as a projections controller that's delegating. So as the event store is updating, as the event store is poking its own events in, it's delegating to the projections like yourself. Projections controller thing is delegating, make your transformation, and here's the store that you can persist this to.
You still have the code that shows the V8 engine running in Postgres as well.
Watch the top right of my screen. Okay, I'll try that again. I don't know why growl didn't work, but if you're just looking to see how this happens in the database, or what are you looking for?
Yeah, there was a demonstration of like your triggers that were running inside the V8 engine that kind of demonstrates the hooks that are in place.
So I don't have any of the listen notify work going on. It is so far it's all stored procedures.
I think it still adds context to it.
You can get there. It's kind of nice in a way because my the main Mac trackpad doesn't work. Can't really use this as sit on the couch with it sitting on your lap. So it's really been positive for work-life balance. In Postgres itself, like appending the events up top, and Corey, for your sake, this probably is going to change and become more Postgres-like. Today I'm offloading almost everything to JavaScript. I think it's going to go the other way around to use the locking. But the top function, this is grabbing an event. So I get a JSON message coming in, and it's smart enough that this could be a single event or it could be an array of events. There's a couple flavors of it, a very JavaScript, mystery beat kind of API, except it'll be documented. And I'm thinking you guys don't believe me about the documentation. This is just a little bit of wrapper to connect this as a stored procedure to Postgres. It's using what they call the PLv8 stored procedure engine. Postgres will let you embed stored procedures in something like 6 to 8 different languages. Python was really common. Python, I think there's Ruby, and V8, I think, is becoming the most popular. PLv8 is a Postgres level global object that's giving us access to the database to be able to execute SQL against the database. What this really kind of feels like is it's really running an application inside the database. PLv8 is your gateway to the actual database. Might be the only one that's ever done this, but I used to do a lot of access development way back when, and it felt like that. You would write just regular ADO code running inside of access, but you had a special ADO connection for the current database, and that's what this feels like to me. And initialization, the process of initialization, and here's the crude common JS implementation. To try to be a little more efficient in initialization, loading all the projections into memory, having those categorized, who applies to what, kind of pre-built. I'm building a couple objects. It is JavaScript. It's all Expando. I'm popping a couple things and methods right onto the PLV8 object. So this global object is the event projector, the projections, the event store. All these JavaScript objects that I'm bootstrapping are going to be available to every session from here on out. They are stateless. They're stateless in the standpoint of there's no state that's really changing, but it's nice to have that collection and kind of the mapping of what are all my projections and what do they apply to. Is that what you're looking for, Corey?
I just think it adds a little clarity as far as how the integration works.
Yeah, in bootstrapping, you look at the actual database. So I do have a command line tool that we would use for, you would integrate in with reg scripts, gulp scripts, whatever it's going to be to seed the database. So it can sweep through, it can help you build out the core schema. Everything for our schema is going to have a PGE underscore prefix, Postgres events. The Node.js naming idiom is to make the package names very succinct. So this on GitHub under my name is PG underscore events. So bootstrapping is going to seed, is going to look and try to rebuild all the event and stream tables. I need to have one that's just reapply the projection changes that I don't have today. It'll see the basic tables, the aggregates table, events, projections, streams, the very core things. You see, I have user in the my testing. I have some user-defined projections for arrival and party, and maybe another one or two in there. For the read side views, to make the querying be a little more efficient, we're building tables on the fly for those. But those tables are really nothing more than a GUID ID and a JSON blob. With Postgres being able to efficiently query inside of the JSON blob, that's all, I'm thinking that's all we're going to need. There's a possibility of creating projections that project to a flat table structure later. I'm not sure how that's going to work. Actually load the projections themselves, get into a table. Oh, well. So I've already had the case on my MacBook Pro replaced once for the to fix the trackpad. It's really a problem with the battery overheating. You have to leave it in the shop for like 3 or 4 days and you have to replace the entire casing to fix it. So I'm putting the entire, the body of the projections in here. The require up here, if you've worked with Node.js or Browserify, Webpack, you've seen that. This is a little bit short-circuited. When the require is running in the database, it's only caring about the file name, and it's looking up by, loading up by file name, and it's doing an eval. I just saw Josh's eyebrows go way up on that one, but it's working. The great thing this is doing for us is it's enabling us to use these projections to test it with Mocha on just regular Node.js, read it to the server, or to run the database without changing that code whatsoever. Just doing a little bit of trickery with the require inside the database itself. When you're writing these projections, you might throw Lodash in on the server side, but maybe not. So you are constrained to very plain Jane JavaScript right now. And I'm just going to wait and see if that's a problem. If that does become a problem, maybe we'll find a way to get Lodash running inside V8 and Postgres. Yeah, it's just that you'd have to manually have those loaded. We'll have to have some way to get those included into the seeding is actually stuffing the modules inside the database where it's available for PLVA in here. So some of the system libraries. So some of the system libraries within PG events actually get shoved inside the database itself, where it's available through the database's own common JS loading. You can see it's not a whole lot. I'll try to ask for that as well. Thank you. You're my hero, Pedro. Guys, I know this is pretty ad hoc, and there's not a huge amount here. What other kind of things would you like to see? The usage on the client, I'll show you that real quick.
I think I could also talk to why Postgres as opposed to something similar to what we're already using. I think one of the technical challenges that we run into with a distributed event sourcing model is that it becomes very hard to ensure things are synchronized. Not impossible, it's just more difficult. And by getting closer to the database engine itself, granted, we are going to have an async processing loop that's going to be kind of batching these updates asynchronously. However, we can leverage something that has really good processing power just as a single process that churns through those as fast as possible, as opposed to a distributed architecture that's doing this as well. That way we can ensure things are processing very fast and staying in sync and not having to look at 5 servers to determine what went wrong with this event that got published.
Kind of my question as well, and I had to say about, so I may have missed it, but in one of your slides you talked about something magical, synchronizing everything. Is that just something magical in the future, or do you have something to demonstrate?
Not today, sometime within the next month. So the notify listen capability in Postgres, the idea that we'd have a background service just to monitor the projections, things that where you're aggregating, where it really has to run in a background process, it really has to be queued. It may be nothing more than a coordinator just calling the right stored procedures inside of Postgres to do the work, or we may embed the V8 engine inside this asynchronous process and perform the projections right then and there.
I guess I'm kind of wondering then, how does that solve the stale data issue?
It doesn't. It recreates the wait for stale events. Maybe we can make it faster. That's TBD. It's a big one.
If you're indicating that it needs to be async, then you're already saying stale data is okay. If you don't want stale data to be okay, then don't use asynchronous events.
You are, I don't know if you were in when I talked about that, you are going to have the option to mark projections as either synchronous or asynchronous. So making them performed in line with the event capture. And that's something we've wanted. Mike, isn't that something you guys have wanted in a few cases?
I mean, with the transactional stuff we did between FT and event store, we're kind of at that right in a lot of ways. Like the new models and normalizers don't go. If the event doesn't go, the normalizers don't go. They're kind of synchronous.
So, I mean, back to the 3 5s and a 10 or 2 10s and a 5. If you want to ditch eventual consistency, we're going to enable that. Slow down the writes, but we're going to be able to have those options. Should even within the same system. The usability from the event, the client isn't much so far. I'm really looking for the new Node.js project to kind of drive the use cases a little more.
The other thing that we're getting from storing the view models in JSON blobs as well is that if you look at it from an API route in SPA or something like an SPA, we're not even needing to deserialize that JSON blob into an intermediate DTO to serialize out as JSON. We can literally take the row that comes back from Postgres and write it out directly to the response stream. So that alone has a huge performance benefit as well as reducing the amount of ETO classes that we're creating in our code.
I haven't done that one yet. I'm putting that off just because it's easy, so I haven't worried about it. That's a huge one. Having JSON everything, just the amount of code that you're going to have to write should go way down. Places where you're not going to be able to have to define a DTO class just to establish the shape of some data. Except I did find it useful, at least from a testing perspective, to go ahead and create a constructor for the event classes. But it's still so much lighter weight than the .NET DTO equivalents.
And also, like, from those of you who have been like using the event sourcing in SQL Server where it stores it as a JSON string or a bar chart column, you're not going to have to do that, like where the string is like some value that you're searching against, because there's literally query operators that you can search against in Postgres. So if you need to drill down inside the contents of the JSON data type, that's not only there, but it's fast because, like I said earlier, it's indexed.
So it's kind of it's an analog to XPath, but I think it's easier. It's cleaner than that. We're going to find out what it's really like. Something, Corey, I think we will do soon is probably create some kind of pre-canned views where you just pass in, you have a way to establish this is what I'm looking for and how I'm going to search. And in usage, you're just going to pass in a hash of arg to value and let it deal with the JSON XPath thing by itself. It's not crazy. It's not as ugly as XPath, but that's what it is conceptually. From the client perspective, drop a client directly on this. It's going to be all promise-based. For anybody that hasn't run into JavaScript promises, you guys have done one of your Friday talks on promises, haven't you? Okay. Which library did you use, by chance?
I actually went with the latest that is like syntax that's supported by Chrome. Because yeah, Chrome already supports some of that stuff.
Okay.
Not the super advanced stuff. But.
So I've been using Bluebird, and I'm pretty happy with it. I think Bob and Matt are using one of the other libraries, but it's a standard, so they all feel the same. It's okay.
So, and did you consider Q? Why Bluebird?
Performance is supposed to be significantly better. But the usage is all the same. The client here, you're going to drop it in. The client is calling stored procedures on Postgres for you, but you don't really need to care about that. These are the kind of methods. Append, and there's a couple different ways you can use it. You can pass in one event. You can pass in a batch of events. Maybe at some point in time, I think, is it possible, Mike, or likely that you'll get a command that may spawn events to multiple streams at one time?
We don't have that in our system, but it might be something we need to be doing because we have a lot of mess because of that coordination between aggregates.
If it's valuable, we'll build that when we need it. So doing the arguments trick to turn that into the message exactly the way the store procedure needs to do it. Up above, just out of curiosity, and I did write a blog post about this particular thing, you see the function star and the yield tquery thing and the append function. So that's a JavaScript generator. In this particular case, using the new Harmony generators, it allows you to use the event loop asynchronous kind of coding and still look mostly like synchronous coding, as opposed to callbacks or the nested promises. These other methods, these two are promise-based. I think I actually tried to rewrite it as a generator, and it wasn't any more clear, so I just reverted it and left it. But what comes back out of all of these views, the return in every case is a promise. So it's like returning a task inside of C#. So you'll always be doing the continuation with it. So just be aware of that. But so far, I can append events. We can fetch the raw event data for a stream if we want to do that. We can grab a named view. So if we have name projections, we can grab it by ID in a view. If there is a current, that fetch current snapshot is probably only useful for testing, but if you want to see what the persistent snapshot is, you can grab that. Maybe we use that to actually replay events on the Node.js side. And you can always fetch the latest aggregate. And that thing that is fetching the latest aggregate, it's always going to give you the latest data. That's where it's using the snapshot and potentially playing forward off the snapshot, which is pretty similar to how Event Store works today, Mike.
Yeah.
In the Event Store.
Here's some raw code that is
I haven't done this, but with the using coed.js as our, at least for now, as our web server framework on the Node.js side, potentially adding some helpers directly to Koa, where you could say post or get routes. You could just declaratively say it's going to be this view, this named view. So we could maybe have some shorthand helpers that would just wire up get the string of this view directly from the database and shove it on the output, the outgoing output. Thought that might be helpful. Any thoughts or questions? Anything that you're using today within
Batteries then.
Oh.
We can go.
I was about to say, I didn't do it.
Here, I'll take it from you.
So I've obviously read using Greg Young's Event Store as a lot of inspiration for doing this. Not creating everything that they have, doing some things that they're not doing. But for those of you who have already used event sourcing inside of our current applications, are you seeing anything that you want that we don't have? Anything you're seeing that's missing from maybe reading about Greg Young's Event Store? Andrew, I know you have an opinion.
Fine. It's fine.
Might have someone take your pulse in a minute.
Do you have an example of actually publishing the events?
publishing the what to the database or to other?
Just seeing you're just seeing the usage. The problem was, oh here, you see, I created a custom test harness to make it faster, and it does hide some of the details of what those things look like. But so what you'd be passing in is going to be looking like things like this. I could, you could be passing it in saying ID, and data. You have to embed the event type inside of it. That's like a $sign type property. The nomenclature I'm using, any JavaScript field that's $sign is something that's really kind of reserved for PG events itself. So you can see at the rawest, if I want to do a batch of events, and this is really simplistic, but I can make a message that's like, here's the event stream I want to use, and if the ID isn't there, it'll assign one for you. It'll build a GUID for you. The type of, that's going to be the quest, or that's going to be the stream type. I think now I'd have to double check. I think I've made that soft enough that it can just detect the stream type off of the event types.
Yeah.
If you define the aggregates, so it won't make you keep specifying all the duplicated information.
That could be the multiple streams that you were talking about earlier.
And we won't cross the streams.
Right.
it's kind of famous. I got upset with Crandall on project when I kept using Ghostbusters references and got I was like 3 when that came out. I don't know it.
So one other thing I wanted to comment on, so in your category-based projections that you talked about, or at least plan to do.
Planned.
The nice thing that that'll give us is, I know specifically for one of our systems, we have misrepresented modeling of aggregates because of our need to show data related to one higher level concept, as opposed to just recording the information at the closest possible source. And because of that, we end up doing this like awkward event coordination between aggregates, and that may not be necessary if we're just recording it at the lowest level and doing a projection based on category. Category in our case could be, clients, it could be carriers,
Like, for instance, in LAC, we have employees and certifications, and then you have this concept of an employee working on certification. That kind of what he means.
Yeah, like maybe the certification is the real thing, and the employee is the category.
I think that the categorization hasn't happened. That's going to have to happen in the asynchronous service, I would think. I don't think that can be done synchronously. Any place where we're worried about the order in which things get applied, and there's a threat of concurrency, that probably has to get offloaded to the mythical async service. But throwing the events in, it's just going to be a little JSON blob. Andrew, if you're batching it up, you're going to have to embed the $ type in each event. If you're throwing in one event at a time, sorry guys, I've slept since I did this. This to-event message, it's got a little bit of logic to interpret your arguments and try to find out what you're really doing. It's like if you want to say, here's the ID and here's the event, it can handle that. If you're going to say, pass in one batch message with an ID property and a data array, it knows how to do that. My theory is we'll beat that with documentation. In use case, if this turns out to be kind of a mystery meat thing and the documentation unit tests don't help you, we'll go to separate overload, separate semantically named methods like send batch, append a batch of events, append a single event, whatever it's going to be to make this usage clear. But I just want to see that kind of flow from actual usage and just work off feedback rather than trying to do that up front. So I guess what I'm saying is just wait and see how this feels, and if this doesn't work, we'll change it. Okay, guys. Again, thanks for having me. Any more questions about this, just send it in, or any concerns, and I will try to have a much bigger blog post about this up sometime next week.
And your GitHub repo is all up to date?
Yeah, GitHub's. It's just under my GitHub account, PG_events. And guys, I'll be here till just after lunch if there's any last minute things you guys need from me. And thank you. Nah, I gotta use that.